Yeah. Good evening, children. Good evening, Santosh. Good evening, girls. Yeah. So last session or last class, we started with algebra. Let's recall before we proceed to the next session. So, all right. Now, tell me let me show you a pattern. Sorry, one second. All right. So here we're trying to create a pattern using the uppercase letter of the English alphabet V. All right. We're using V, uppercase V, to build a pattern. What is the first term? There is only one V. The second term has two V's. The third term has three V's. So you understand, the 10th term will have 10 V's. The 100th term will have 100 V's. All right. Next question. How many, you all understand, these are matchsticks. All right. So how many matchsticks are needed to make one V? Two matchsticks. Two matchsticks, right? So we need two matchsticks to make one V. Okay, so that is to get the first term. This is the first term. This is the first term. This is the second term of the pattern. This is the third term of the pattern. Okay, this is the first term of the pattern. This is the second term of the pattern. This is the third term of the pattern. Okay. So we know that we need two matchsticks to make one V. All right. So we know that the first term has one V, second term has two V's, third term has three V's, and so on. Now the question is to make a general rule. What is the question? Make a general rule to find out how many matchsticks are required to get some particular term of this pattern. You want to find the number of matchsticks you would need or you would require to get, say, the 50th term of this pattern. So we know that the 50th term will have 50 V's. Now, how many sticks will be required? 100 sticks. Now, we need to make a generalized rule. So what is the rule? So to make one, so you know that the 50th term will have 50 V's. The first term has one V, the second term has two V's, the third term has three V's. So the 50th term will have 50 V's. Okay, so now for one V you need two sticks. So for 50 V's you will need 50 into 200 sticks. So what is the general rule? So for one V, okay, so for one V you need two sticks. So for n V's and n V's, two n sticks. You will need two n sticks, right? where n represents a particular term of this pattern. Where n represents a particular term of this pattern. Now, when you say 2n, what will you substitute for n? Now, if you want to find the if you want to find the number of matchsticks you need to get the to make the 75th term, So then n will be 75. Okay, so the number of matchsticks will be 2 into 75, which is 150. Yeah, 2n meaning 2 into n. 2 into n. Okay, and what should you substitute for n? Whichever term you want to find. Okay, if you want to find the 40th term of this pattern, if you want to find the number of matchsticks needed to make the 40th term of this pattern, then n will be 40. So 2 into 40, 80 sticks you need. 80 sticks. All right. So like this, you've seen many rules in the last class, like 2n, 3n. So if to make a particular letter, you need 3 sticks, then 3n will be the pattern. If for a particular letter, you need 4 sticks, then 4n will be the rule, not pattern, rule. 4n will be the rule. All right. Okay. Now, this is one case. The other case you saw in the last class is that how many sticks? 3. Are there 2 triangles here? Here there's 1 triangle. Here there are 2 triangles, right? But how many sticks? This is a pattern. What is this? This is the pattern. This is a pattern. This is the first term of the pattern. This is the first term of the pattern. This is the second term of the pattern. All right. Now the third term. How many sticks are here? 3 sticks. Here, how many sticks? 5 sticks. Here, how many sticks? 1, 2, 3, 4, 5, 6, 7 sticks. Count. 7 sticks. Correct? 7 sticks. This is the third term. This is the third term. This is the fourth term. Excuse my, it's not very neat, but you understand what I've drawn. How many sticks? There are 4 triangles. You can see here. The first term has 1 triangle. The second term has 2 triangles. The third term has 3 triangles. The fourth term has 4 triangles. You can count 1, 2, 3, 4 triangles. Correct? Yeah. Now, how many sticks? 1, 2, 3, 4, 5, 6, 7, 8, 9 sticks. Right? Now, you want to make a general rule. Okay. If anybody comes and asks you, I want to find the number of sticks needed to get the 15th term. The 15th term. Okay. The 1, 5. Okay. The 15th term. You should be able to. So if you have a rule with you, you can just substitute the value for n in that rule and get the answer. So that rule is what you have to generate now. What is this? This is a pattern. What is this called? It's a pattern. And whatever you see there are the terms of the pattern. The first term of the pattern, the second term of the pattern, the third term of the pattern, and so on. The first term of the pattern has 3 sticks. The second, to make the second term of the pattern, you need 5 sticks. Third term, 7 sticks. Fourth term, 9 sticks, and so on. So now what is our, what is that we have to do? Or we have to construct a general rule. Okay. Now, to construct the general rule, you need to first find the difference. What is the difference? 2 is the difference. Always multiply that with n. You can also say x. The variable can be anything. You can say 2a, 2b, 2c, 2d, any letter, any lowercase letter of the English alphabet. So normally n. So find the difference 2 and multiply that with n. So 2n. Now give 1 for n. Let n be 1. Let n be 1. All right. So what is 2 into 1? 2. But how many sticks are there in the first term? 3. See, when you give n as 1, you should see how many sticks are there in the first term. When you give n as 1, 2 into 1 is 2. But there are 3 sticks here. So how will you get 3? 2 into 1, 2 plus 1, right? So 2n plus 1 is the rule. I can tell you for the second term. I'll tell you for the second term. See here. Now take n as 2. 2n plus 1 is a rule. Okay. Now take n as 2. When n is 2, I think for Satakshi, I'll come from the beginning. You look confused. 1 second, I'll come from the beginning. The difference is 2. Is that fine? The difference everywhere is 2. Yes or no? Yes. Multiply that with n. Is that okay? Now, you see the rule can be 2n itself. The rule can be 2n itself, or it can be 2n plus something or 2n minus something. For you, only these are the only 3 possibilities. The rule can be 2n itself. How did you get 2? The difference is 2. And n, 2n. So the rule for you can be 2n itself, or it can be 2n plus something or 2n minus something. Only these 3 possibilities you will have. Okay, now I'm saying let n be 1. N be 1. So what is 2 into 1? 2, right? Okay. Now you've taken n as 1. That means look at the first term. If you take n as 1, look at the first term. What's the answer you should get? You should get 3. But you're getting only 2. So how will you get 3? Plus 1. So the rule is 2n plus 1. And that will work for everything. Now let's take n as 2. Supposing n is 2. Okay. Now suppose n is 2. N is 2. All right. So what is that we have right now? We have only 2n with us. We have only 2n with us. Now n is 2. So 2 into 2. 2 into 2. Why 2? Because n is 2, right? You're taking n as 2. So 2 into 2 is 4. But what's the number of sticks for the second term? 5. But you're getting only 4. Plus 1. That is why the rule is 2n plus 1. And that will work for any term of this pattern. Sure?
Suppose we are seeing the fourth term and we are making the n as 3.
No.
Sorry.
If you take n as 4, you should get the answer as 9. If you take n as 3, you must get the answer as 7. If you take n as 2, you must get the answer as 5. Add or subtract. You don't know. It depends. You may have to add or subtract also to get that answer. Again, 1 or 2, something like that only it will be. It'll be adding like how you add 1, 2, 3, 4. Maybe you have to subtract 1, 2, 3, 4. So what's the difference? 2. So 2n. Now let's take n as 4. If you take n as 4, what's the answer you should get? 9 you must get. You take n as anything. But if you take 4, you should get 9 as answer. If you take 3, you should get 7 as answer. So let's try n as 4. So what is it? 2 into 4. Correct? What is 2 into 4? 8. But what's the answer for the fourth term? 9. You have only 8. How will 8 become 9? Plus 1. So 2n plus 1 is the rule. You don't have to check for everything. Take n as any one value. 1, 2, 3, 4. So any one. From that you'll get the rule. So if you try with the fourth one, n is 4. So 2 into 4 is 8. But the answer there is 9. So how will 8 become 9? 8 plus 1. That means 2n plus 1 is the rule. All right. Is that fine? All of you? Okay. So I said the rule can be if the difference is, supposing the difference is 4. Supposing the difference is 4, the rule can be 4n, or the rule can be 4n minus something or 4n plus something. All right. And what is this rule used for? If you want to find the number of matchsticks needed to make a particular term, maybe the 10th term, the 20th term, the 1000th term, the 50,000th term. You want to know how many matchsticks will I need if I have to build that 50th term of the pattern? How many matchsticks do I need to build that 50,000th term of the pattern. You get the terms, you get the words that you'll have to use for the question. How many matchsticks do I need to make the 50,000th term of the pattern? So you can't count, no, you cannot draw and count. It becomes impossible. So you need a rule. So using this, if it is this one, if it is for this pattern, the rule is 2n plus 1. So for the 50,000th term, 2 into 50,000 plus 1. So 1 lakh plus 1. 1 lakh and 1 matchsticks you will need to build the 50,000th term of this pattern. All right. Yeah.
Why should we get the right answer of 1 lakh? Why should we add 1?
Others have understood. You're getting too confused. That's all it is. All right. Yeah. So next into this. So last class was all about patterns. Last class was all about patterns. I'm preparing an assignment for you on patterns. As soon as it's ready, I'll share it with you. And the assignment will be from Exceed. So in Exceed, I think block number 17 and 18. Block 17 and block 18 is algebra and algebraic expressions. So I'll share the assignment which I shared will be the questions from Exceed. All right. And what we're doing now is Agarwal. What we'll do in the class will be a combination of NCERT and RS Agarwal in the class. And the homework will be Exceed. All right. Sometimes I might do Exceed in the class and give you homework from Agarwal. So it'll be a combination of all these 3 books, NCERT, RS Agarwal, and Exceed. And this is, I think, chapter 8 in NCERT, correct? 8, 11. Okay, so this is chapter 11 in NCERT. This is block 17 and 18 in Exceed. I have to check Agarwal. I think it is 8, chapter 8 in Agarwal. All right. Now today we shall learn how to construct mathematical expressions. Okay, so today we learn how to construct mathematical expressions using variables and constants. Last class I told you a variable is a symbol. A constant is also a symbol. A variable is a symbol that assumes any numerical value. A constant is a symbol that takes a fixed numerical value. Like, for example, the number 10. It takes a fixed numerical value, which is 10. This is simple. See, it's a kind of drawing, right? You have to use these 2 symbols to get the value of this number, which is 10. So this one is a constant because 10 is 10. But if I say x, x can take any value. X can be 1, x can be 2, x can be 3. So both constants and variables are symbols. The 2 symbols we use in mathematics are constants and variables. Constants are numbers because they have a fixed numerical value. Variables are represented using small letters in the English alphabet. Small letter A, small letter B, all right, and so on. Now, a combination of constants and variables will give us an algebraic expression or a mathematical expression. Now, say there are 2 friends, A and B. A has, okay, I don't want to say chocolates. Let's say they're small kids. A has some 10 toys and B has 15 toys. What is the total number of toys A and B have together? 10 plus 15, correct? 10 plus 15. So you just have to add 10 and 15. So the mathematical operation you use here is addition. A has 10 toys, B has 15 toys. If you want to know how much they have all together, you need to use the mathematical operation addition. And it's 25. Consider this case where you know that A has 10 toys, but you do not know how many toys B has. You don't know how many toys B has. So then you will say, let B have X toys. We don't know, no? I don't know how many toys B has. So we'll suppose or we'll assume that B has X toys. Now, what is the number of toys A and B have altogether? 10 plus X. 10 plus X. Now, if I say, now supposing later we find out that B has 7 toys. So it will be 10, X is 7, X is 7. Because later we find out that B has 7 toys. So that means X is 7. So 10 plus 7, 17. So X can take 7. But supposing we find out that X has 11 toys. That means X can take 11 also. That's why we call X a variable. X is a variable because X can take 7, X can take 11, X can take any number. That's why we call it a variable. Okay, so if you know that A has 10 toys and B has 15 toys, then in all they have 25 toys. But if you know A has 10 toys, while you don't know the number of toys with B, then you call the number of toys with B as X, Y, or Z. And the total number of toys will be 10 plus X. Correct? Now, if supposing you find out that X is 3, if X is 3, then they have 10 plus 3, which is 13 toys. Now we understand that the variable X can take any value. Any value can be 3, 7, 11, anything. And what is the other thing you understand? This one is an algebraic expression. Algebraic expression. Why is it an algebraic expression? Because see, it's made up of a constant 10, a variable X, and a mathematical operation addition. An algebraic expression is a combination of constants, variables, and mathematical operations. There can be only one mathematical operation. There can be all the operations, or that's what we say. An algebraic expression is made up of constants and variables connected by some or all mathematical operations. By some or all the mathematical operations. So here the algebraic expression 10 plus X. The algebraic expression 10 plus X has the constant 10, variable X, and the mathematical operation addition. Yeah. Now, your questions? You cannot find the answer as long as you do not know the value of X. Yes, your question? Right. Now, let me ask you a general question. Complete this pattern, right? Complete this pattern. What will be the next 2 terms of this pattern? What will be the? I don't want you to make a rule or anything. I don't want 2n plus 1. I don't want a rule. I want you to tell me the next 2 terms of this pattern. Yeah. 21 and 21 and 25. Very good. 21 and 25. Because 5 plus 4 is 9. 9 plus 4 is 13. 13 plus 4 is 17. 17 plus 4 is 21. 21 plus 4 is 25. So 17 plus 4, 21. 21 plus 4, 25 are the next 2 numbers in this pattern. All right. Okay, try this.
Something and 16.
Yeah, tell me.
73 and 70.
73 and 78. No.
83 and 78. 83 and 78.
83 and 78. Correct. The first dash is 83 and the second dash is 70.
What's
So 108 minus 5 is 103. 103 minus 5 is 98. 98 minus 5 is 93. 93 minus 5 is 88. So the next number will be 88 minus 5. 88 minus 5, 83. And the next one will be 83 minus 5, which is 70.
See, it's fine.
Got it? Okay, now complete this one. So it may not always be, a term plus or minus something. It can be a different pattern also. The pattern can behave differently. You need not always get the terms by adding or subtracting a specific value. It can be different. Yeah. So I'll give you a clue. This is not by adding or subtracting any fixed value. It's something else. Think. Twin? No, darling. Let's see, the values are increasing. 1, 4, 9, 16, 25. So it cannot go down now. It has to be greater than that. Both the numbers must be greater than 25. No.
After that 28 is 5. So 28 is 5.
I'm saying no.
Put any letter here. You see algebra. It is like the 125
You know what? It's like, Santosh, when you're thinking like beyond what is needed for this sum. So you're saying letters can be used. Then I can say drawings can be used. See, it's like you're going to an ice cream parlor where they serve only ice creams and you're asking for a cake. It's like that. You know you're in an ice cream parlor, but you want a cake. You want to order a cake. You can see only numbers here, and you're saying the next two blanks can be letters. Then I'll say pictures. Then somebody will say something else. No, we're not wasting time talking. Yeah. They have to be numbers. All right. So this pattern behaves like this. The first one, see what you see here are the squares of the natural numbers. The numbers you see in this pattern, the numbers or the terms you see in this pattern are the squares of natural numbers starting from 1. So the first one is 1 square, meaning 1 into 1, 1. The second term is 2 square. 2 into 2, 4. Okay, 1 minute. Let me make it look simpler because it is very simple. 1 minute. Now, natural numbers, all right. 1, 2, 3, 4, 5, 6, 7. All right, natural numbers, okay. Okay, I'm squaring them. 1 square. Now you will ask me, what is this 1 square? 1 square means 1 into 1. Then 2 square, meaning 2 into 2. 3 square, 3 into 3. 4 square, 4 into 4. 5 square, 5 into 5. 6 square, 6 into 6. 7 square, 7 into 7. So see here, 1 square is 1. 1 into 1 is 1. 2 into 2 is 4. 3 into 3 is 9. 4 into 4 is 16. 5 into 5 is 25. So the next one will be 6 into 6, 36. And 7 into 7, 49. Now just tell me if you understood or no. Satakshi. You got that? Okay. All right. Okay, this is. Yeah. Similar to the earlier one. Yeah. No, I said put everything inside your bag. No noise. Put your pouch and everything inside your bag. Satakshi.
So we should write the number, natural numbers there from 1. After that, we should multiply with the number placed in the.
All right. So this is 1 into 1 into 1. Multiplying 1 with itself 3 times. 1 into 1 into 1. That is 1 cubed, which is 1. Then 2 into 2 into 2. 2 cubed, which is 8. Then the third term is 3 into 3 into 3. 3 cubed, which is 27. See here, 1 cubed means 1 into 1 into 1. 1 multiplied with itself 3 times. Then 2 cubed means 2 into 2 into 2. What is 2 twos are? 4. 4 twos are 8. The next term is 3 cubed. 3 into 3 into 3. 3 into 3, 9. 9 into 3, 27. So now guess the next one. What will be the next one? 4 cubed, right? Which is 4 into 4 into 4. What is 4 into 4?
4 into 4 is 16 into 4 is
64. And the next one should be 5 cubed. What is 5 cubed? 5 into 5 into 5. Tell me the product.
5 into 5 is 25.
All right. One. One second. See here, patterns are different. For different patterns, we use different rules. Different patterns, we use different rules. You cannot use the same rule for every other pattern. Now, in this pattern, the numbers are generated by cubing the natural numbers. Understand? All right. So this is one thing. All right. Now, listen to the instructions carefully. I want you all to use 2 operations. Okay, use 2 operations. All right. Maybe multiplication and subtraction. And create a rule. For example, in the rule 2n minus 1, we have two operations, 2n, where it is 2 into n. So multiplication and subtraction. Correct? Correct? Yeah. Now I want you to construct a rule like this. Don't use large numbers like 5,000 and 5n and all that, and we'll have to just spend a lot of time calculating them. Use simple numbers, numbers less than 10. Okay. So I wanted to create a rule using two operations, at least two operations.
But I have multiplication cancel. For division and subtraction.
Division, it will be 2 by n.
By simple.
2 divided by n.
Subtraction.
Okay, let me make it very specific. For subtraction, it's minus. Now, okay, let me make it more specific. Use only multiplication and subtraction. Can we? Use n. You can use anything else, but now you use n only. You can use. Yeah, what's your rule? 5n? 5n minus 2. Okay, so generate the terms using your rule. 1 minute. Stop, all of you. Listen to Santosh. Now, Santosh, so this is Santosh's rule. Okay, this is Santosh's rule. And now Santosh is going to generate the terms of the pattern using this rule. Using this rule 5n minus 2, he is going to generate the first 4 terms of the pattern. The first 4 terms of the pattern. Yes, Santosh, what will be the first term?
First time we should draw figure.
Don't draw. I just want the number. Take n as 1. Take n as 1. You should take n as 1. Why? Because you want the first term. So n should be 1. Tell me.
First term. Okay. First term you should draw. Okay. You should write 5, and then it's 10, and then it's 25.
Okay. No, you have not understood. 5n minus 2 children. So when n is 1, it will be 5 into 1, right? 5n means 5 into 1.
No.
Minus 2. What is 5 into 1? 5. 5 minus 2 is 3. Okay, so this, listen to me, 1 minute. When n is equal to 1, correct? 5n minus 2 will be 5 into 1 minus 2, which is 5 minus 2, because you'll have to multiply, which is 3, correct? Next, Satakshi, tell me when n is equal to 2. You have to take 2. Minus 2 will be 5 into 2. 5 into 2 minus 2. The rule. So that will be, what is 5 into 2? 10. 10 minus 2. What is 10 minus 2? 8. So that's the next one. When n is 3. When n is 3. Five into 2. What is 5 into 3? 15. 15 minus 2. And that is 13. Then when n is 4. Five n minus 2 will be equal to 5 into. What is 5 into 4? 20 minus 2, which is 18. So what are the first 4? What are the first 4 numbers of this pattern? The rule is 5n minus 2. So the first 4 numbers are 3, 8, 13, and 18. You can, now supposing you want to find, Satakshi, if you want to find the 50th term, then it will be 5 into 50 minus 2. Yeah, n becomes 50. If you want to find the 50th term.
Oh, no. I thought
All right, so it will be 250 minus 2, which is 248. Yeah, now somebody else. Yes. 9n minus 3. Okay, so she says 9n minus 3. So what are the two operations you've used here? Multiplication and subtraction. Satakshi, are you following that? You? Yeah. Yeah. Now generate the terms when n is equal to 1. 9n minus Satakshi, you must look at the board. Is equal to. So what is 9 into 1? Next one. Next, when n is equal to. Now you can't take n is 7. You have to take 2 because you want to get the first 4 terms. First 4 terms meaning n is 1, n is 2, n is 3, n is 4. So when n is 2. Tell me.
Yeah.
Fast, fast. Very good. Santosh?
Yeah. When n is equal to 3, now 9 minus 3 equal to 9 into 3 minus 3.
9n into 3. What are you saying? Slowly. 9n into 3, yeah? N is only 3.
N is only, sir, 9 into 3 minus the equal to it's 27. Minus 3 is equal to 25.
Satakshi, when n is 4? Oh, 24, sorry. Hey, 24, yeah. When n is 5? Sorry, when n is 4, Satakshi? So what are the first 4 terms, Satakshi? Of if you for this rule 9n minus 3, what are the first 4 terms? How should I write? I'll write 6, 15, 24, 33. Yeah, 6. 6. What is the separator? How will you separate 2 terms? With a comma. 6, comma, 15, comma, 24, comma, 33. And it goes on like that. It goes on like that. Now, if you want to find the 11th term, what will you do, Satakshi? If you want to find the 11th term, you want to know what will come in the 11th place. What will you do? Now, work that 9 into 11 minus 3 is what? 9 into 11 is 99. Minus 3, 96. So, the 11th term will be 96. Yeah. Which one? No, I just want the rule now. We are already done. Yeah. What's your rule? 7 and minus 3. What's your rule? Correct. 4 and minus 1 is your rule. Very good. Now, what's the question? What is the question? I said construct a rule. I said construct a rule and I said use 2 operations. And I also specified the operations. I said you should use multiplication and subtraction. So where is multiplication in 9n minus 3? Where is multiplication? Here, 9 into n. 9n means 9 into n. And where is the other operation? Minus. We understand that?
We can do the rule 3 operation.
3 operations.
Yeah.
For you, no. Because.
No.
Yeah, see, I'll write.
Oh, into 2.
You can create. But for you, we stop with only 2 operations. All right. Now, I want you all to So I'm showing you, this is a pattern. Okay. So in the first term, this is the pattern. The first term has one square and one triangle. The second term has two squares and one triangle. The third term has three squares and one triangle. The fourth term has four squares and one triangle. Now the question is, what is the general rule for this pattern? This is the pattern. What is the general rule for this pattern? Find out. So tell me, how many matchsticks for the first term? 6 matchsticks for the first term. Very good. How many matchsticks for the second term? 1, 3, 4, 5, 6, 7, 8, 9 or 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. The third one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh God. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Next. Counted? All right. Very good. Now tell me the rule. What's the difference? 3. Now take n as, now if you take 1, if you take n as 1, what should be the answer you should get? If you see 3 is the difference, then you should write 3n. Okay, now if you take n as 1, what should be the answer? 6 should be the answer. If you take n as 2, what should be the answer? 9. If you take n as 3, what should be the answer? If you take n as 4, what should be the answer? You take anything, but take any one. Don't try all the 4. One will do. One will do. Okay. So you can, if you want, you can take n as 4. Anything you can take, but take one and frame the rule. Now, I said difference is 3. Is that understood? Then 3n. Okay. Now you're taking n as what? Do that in the rough column. 3n. You're taking n as 4, right? You're taking n as 4. So 3 into 4. What are you getting? 12. But what answer should you get? 15. So 12 plus what is 15? Plus 3 is 15. So then what is the rule?
So 3n
plus 3 is the rule. 3n plus 3 is the rule. That's all. It's as simple as this. So now what do you realize? When you repeat, so the thing is you've understood, but you need to repeat. When you hear it for the first time, since it's new, you feel it's difficult. And as Santosh was going on saying, I did not understand, I did not understand. That is what it is. This repetition you should do at home. That's what it is. Every time you learn, for everybody, even if I learn something new for the first time, say I learn some shlokas. Okay. So I attend some classes on Bhagavad Gita and I'm learning. See, I don't know. Though I want to learn, I don't know. So say I enroll and the guru teaches me some shlokas. So when I recite along with the guru, I'll be able to do it because she's prompting. No, every time she's prompting, and maybe I'm looking into the book and reading, but it will not be an easy go. It will be difficult for me, but I'll manage with the help of the guru. I'll manage. But if I say after 2 days, I open the book and try to read it by myself at home, it will be difficult for me because it's new to me, right? I haven't read it earlier. It's completely new, like the syllabus is for you. So I'll be like struggling with the pronunciation. And I'll be like, oh, that day I read it, but why I'm not able to do it again today? So maybe if I have the recording, I'll play the recording. If the teacher has given me the recording, I'll play the recording. I'll listen to it. Then again, I'll try to go with the teacher. So like that, I need to practice with the recording. Once I practice with the recording, then you master it. How can I expect, even if she's the best teacher on earth, how can I expect the teacher to make me memorize the first time she teaches me? That's not possible with anything. Everything is an art. And to master the art, you need to practice regularly. So don't get scared. Okay, when you learn something, when you're seeing something for the first time, you will understand, but your mind will say, no, you have not understood. It will be like that. You have to practice. That repetition can be done once more in the class, but I can't do it 4 or 5 times, right? We need to move ahead. I can teach you, but repetition, you have to do at home. Once you repeat, what you thought was difficult will be like, oh, it's so easy. To make that difficult thing easy, you have to practice.
They give us the rule and they have to draw what diagram we should choose.
No, that's difficult. For a student, that's difficult. As student, that'll be difficult. So you don't expect that question at all. Now you understood this here? Yeah. So what is the first step, children? Is to find the difference. Correct? What's the difference? So when you practice at home, you should recall this. You should recall the steps. You should not stare at the rule and like scratch your head. How did she write this? I don't know. Not like that. How was this explained to you? I'm saying first find the difference. 3. Then I said put n, meaning 3 into n. Yes or no? First step difference and then multiply that with n. So 3n. Now you know that you should add something or subtract something. Or maybe it is 3n only. See, all this you should recall when you're practicing at home. So now what you will do? You will say, okay, let me check with the third term. This is 1, 2, 3. This is the third term, right? So you'll say, okay, let me check with the third term. So you'll put n is 3. You'll put n as 3. So what is, if in 3n, if you take n as 3, it is 3 into 3, right? What's the answer? 9. But what answer should you get? Why, Satakshi, you're not answering? When you take n as 3, what is the answer you should get?
Oh, the third should be that.
Yeah.
So
So when you take, see here, this is 3, third term. The answer should be 12. So when you take n as 3, 3 into 3, 9. But what is the answer you should get? 12. How will 9 become 12? Plus 3. So what is the rule? 3n plus 3.
you should get the term.
You should get the value here you have. You have to get 12. Yes, you should get 12 as the answer. You have to get 12 as the answer. Now let me write a random pattern, okay? Like say, okay, like this. So what's the difference? 7. 7, what's the next step? 7 into n. That's the next step. Now, this is the first term. This is the first term. This is the second term. This is the third term. This is the fourth term. So here the diagram is not given. The directly answer you have. See here you have, oh, I erased it. Okay. You don't have the, see now you'll count the matchsticks and write the answer, right? That number I've given you straight away. Without the diagram, I've given you the number straight away. 8, 15, 22, 29. These numbers actually you will write after counting the matchsticks. So here I've not given you the diagram. I've given you the matchsticks, the number of matchsticks straight away. All right, the first term, you need 8 matchsticks. For the second term, you need 15 matchsticks. For third term, you need 22 matchsticks. For the fourth term, you need 29 matchsticks.
So
Now 1 minute. So the difference is 7, correct? Into n, 7n. All right? Yeah. Now 7n. When you take n as 1, so 7 into 1 is what? 7. But when you take n as 1, what is the answer you should get? 8. So 7n plus 1 is the rule. That's all. Now supposing you put 3, 7n. You have 7n. In 7n, supposing you put 3. What will you get? 7 into 3? 21 you get. But for the third term, what answer you should get? 22 you must get. So plus 1. So 7n plus 1 is a rule. So now going back to, constructing mathematical expressions. Okay, actually, what we saw earlier, I was telling you about the toys A and B have. So 10 plus 15, 25. Remember, sometime back we were talking about this. Yeah. So this one, 10 plus 15 is a numerical expression because it's only made of numbers. It's only made of numbers. See, you can say two things. You can say it is an algebraic expression, or you can say it is a numerical expression. Okay, see, now you're expressing. Yeah, you're expressing something. So you seem to be very happy, very excited, very carefree, stress-free. Yeah. Now, you're waiting for the next question. Your face says that, okay, what is the next question? Something that maybe I'm not right in guessing. So your face says something. No, you're expressing something. See, the Tanya's so happy. Yeah, so like that, numerical expressions. Numerical expressions, algebraic expressions. All right. So when we say numerical expressions, it's made only of numbers. So 10 plus 15 plus say 20 is a numerical expression. Why numerical expression? Because there are only numbers 10, 15 and 20. Yeah, numbers along with operations. Yeah. Now supposing I write 10 plus x. This is not a numerical expression. This one is an algebraic expression because you can see the constant 10 and the variable x and the mathematical operation addition. So if it's only numbers, numerical expression. If it is numbers and variables, it is an algebraic expression. And a mathematical operation. All right. Okay. Now, if there's only one term, now supposing I write x plus 10. Okay, or supposing I write only x. This one is called a monomial. Monomial. All right. Monomial. If the algebraic expression has only one term, it's called a monomial. If an algebraic expression has two terms, like this, 1, 2. Now, how do you count 1, 2? The separator is a plus or minus sign. Like we have separator, comma. Okay, now if I write 4, 5, 8, 7, 6, is this one number or four numbers? One number. It's only one number. 5,876 is one number. Now, supposing I write it like this. Now there are four numbers because I've used a separator, comma. Comma separates the numbers. In the same way, in an algebraic expression, the plus sign or the minus sign separates the terms. How will you say 1, 2, 3, 4, 5? How will you count the terms? The plus minus signs are the separators. The separators are the plus sign or the minus sign. Like the comma here. Okay. Now if I write x, y, z, this is only one term. But if I write x plus y minus z, plus and minus are the separators like comma. You should look at the plus like a comma. You must look at the minus like a comma. If you see a plus sign, comma. If you see the minus sign, comma. Think like that in your mind. So three terms are there. Three terms. If you see a plus or a minus sign, treat it like a comma. If you see a plus or a minus sign, treat it like a comma. X plus y, that means x comma y. So two terms, minus z. X plus y minus z. So just treat this like a comma. Treat this one like a comma. 1, 2, 3 terms. Correct? If I write A, B, C, D, E, F, G, H, I, J. How many terms? Only one term. I don't see plus minus sign at all. Only one term it is. But if I write A plus B minus C plus D, E, F, minus GH plus IJ. Plus, it's a comma. Minus is a comma. This one is a comma. This one is a comma. This one is a comma. 1, 2, 3, 4, 5, 6 terms. No, I'm concerned why Satakshi is confused. You are not. No, you are not. You're clear. Okay. Okay. I said, if it's a plus or a minus sign, treat it like a comma. Okay.
That's the plus or minus. It is a comma. Can you like that?
No, it's not a comma. Plus is plus only. Plus cannot become a comma. You cannot replace the plus sign with a comma. You can treat it like that in your mind, not in your book. You cannot remove that and put a comma there. Plus is a plus. Minus is a minus. You treat it like a comma and count. So A minus B plus CD minus E, F, G. Okay. So 1, 2, 3, 4 terms. Correct? 4 terms. Now, read it. Monomial. All right. Binomial. Trinomial. Quadrinomial. Quadrinomial. Don't we say quadrilateral? 4 sides. Triangle, 3 sides. No, not quadrilateral triangle. No, quadrilateral. Monomial, 1 term. Binomial, 2 terms. Trinomial, 3 terms. Quadrinomial, 4 terms. Now, supposing there are many terms, then you can in general say multinomial. You can say multinomial. For a monomial, you should not say by a multinomial. But for a binomial, you can say. If it has more than 1 term, you can say multinomial. Binomial is a multinomial. Trinomial is a multinomial. Quadrinomial is a multinomial.
Everything what is
Multinomial. Four terms.
Yeah, terms it does yes.
No, 4x has a different meaning. 4 terms.
Yeah.
Okay, if you count the number of terms and there are 4 terms, it's a don't write anything. I'll share the notes later. If you count the terms and there are 4 terms, it is a. If you count the number of terms and if there are 4 terms, it is a quadrinomial. If there are 3 terms, trinomial. 2 terms, 1 term, monomial. Monomial. All right. Now let's understand how to convert a statement in English to an algebraic expression. How to convert? No, I can make a statement in Kannada also. Utta aita? What is a statement? No, one more thing is, see, you're young, so I have to tell this very patiently. I have just started something. How do you expect yourself to understand even before I say anything? You have to wait. You have to wait. See, my work is to not say something. Say something so that it's clear to you. I should not be making noise. Wait, I just started. Yeah. So now what we're going to do is, or what we're going to learn is how to convert statements in English, because there are so many languages. No, you can make a statement in any language. All right. So how to convert a statement in English to an algebraic expression? Okay. So English to maths, converting from English to maths. Like I speak in a particular language. There is a translator. So I talk Tamil. So I'm at the US Embassy. Definitely I cannot follow the English. The person at the embassy is going to talk to me. So I choose my convenient language, Tamil. All right. If ever I wish to go to the United States, I need to get my visa, right? Okay, I have a passport, but I need to get a visa to travel. So I have to visit the embassy at Chennai, and I need to meet the concerned authority there to get my visa processed, right? So then I have to choose a convenient language. And the convenient language is definitely Tamil. My mother tongue is the most convenient language for me. All right. So then, but the person at the embassy, the US representative, he understands only English. So then there's a mediator, there's a translator. So I say something in Tamil, the translator translates that to English. Right?
Yeah.
So sometimes we see news also, right? News which is in English is translated to a different language. Somebody is reading and then there's a translator putting it in a different language. Okay, in the same way here, we're going to see statements in English and we're going to convert that to mathematical expressions or algebraic expressions. What now? All right. Now, how do you express the, now this is in English, the sum of, okay, the sum of 5 and a number. The sum of meaning addition, 5 and a number. What number? X.
So 5 plus X.
That's it. Or 5 plus A, 5 plus B, 5 plus X, Y, Z. Yeah. Because 5 is 5. The sum of 5 and a number. What is a number? So 5 plus X. So you see, you've converted this statement to an algebraic expression. 5 plus X. That's all. All right. Okay. Now, how do you express the difference of 5 and X? The difference of 5. The difference of 5 and a number. The difference of 5 and a number. 5 minus Y. Anything. The product of 5 and a number. The product of 5 and a number. 5 into Y or 5Y. Okay, the quotient of 5 and a number. The quotient.
How?
5.
Oh, no, I understand.
Now the quotient of 5 and Y. The quotient of 5 and Y meaning 5 by Y. So sum meaning addition, difference, subtraction, product, multiplication, quotient is division. Yeah. Yeah. 3 more than 3 more than a number X. See, whenever, see, in while finding the difference, we have learned something from our teacher, no? When we were young, what has the teacher told us? If I say subtract 15 from 30, what should we write? Whatever comes after from should be written first, right? 30 minus 15, which is 15. Whenever it's subtraction, whatever comes after from should be written first. So 30 minus 15. In the same way, whenever you see this word than, more than, less than, more than, less than, whatever comes after that should be written first. So more than X, no, X should be written first. And if it is more than, it is addition, 3. So 3 more than a number X is written as X plus 3, not 3 plus X. Both are the same. The value is the same. But this is the right way of representing. See, you say 3 plus X, X plus 3, both are the same because addition is commutative. Addition is commutative. That's right. But converting this exactly to an algebraic expression is X plus 3 only. Okay. whenever you see the words more than, less than, more than or less than,
More than
whatever comes,
more than means addition, less than means subtraction.
correct. Whatever comes after this than, more than or less than, what comes after that? X. That should be written first. And then if it is more than, addition. If it's less than, subtraction. And this number 3.
But
So,
next one we access.
okay, so 3 more than a number X is written as X plus 3. Yeah. Santosh, second one, answer the second one.
6 minus 1.
6 minus Y. Very good. 6 minus Y. We understand? Because what is after less than? What is after that? 6. Less than means minus. And then Y. Yeah. Now the third one. So 1 second. 1/3 of the sum of X and Y. How do you write the sum of X and Y? Just that sum of X and Y. X plus Y. 1/3 of is an operator. Of is an operator which stands for multiplication. Of is an operator that stands for multiplication. 1/3 is 1/3. So see here, just look at the way we write it. See here, 1/3 means 1/3. Of means into. The sum of X and Y means X plus Y. So it is 1/3 into X plus Y. X plus Y in a bracket. That's all. 1/3 means 1/3. 1/3 means 1/3. All right. Of means into. Sum of X and Y means X plus Y. So put everything together. 1/3 into X plus Y. Now you can also take away the multiplication sign. You can also write it like 1/3 without that sign, like this. When there is no sign, that means it is multiplication. When there is no sign, it means it's multiplication. Yeah, now I've finished. Now ask me your questions. No. Quarter is 1/4.
Yeah,
And half is 1 by
2.
2. Half is 1/2. Quarter is 1/4. 3/4 means 3/4. 5/6 means 5/6. Yeah. Fourth one, yes. Minus. Very good.
Oh, less than. Less than.
Yeah. Try Satakshi. All of you keep your answers in your mind. I got it from Tanya, the others. She may be right or wrong. I will say yes for both. Then finally, then I'll say the correct yes or no. So don't believe me. No, are you looking at the fourth one, Satakshi? No. Oh, because she answered the fourth one, you thought fifth one is yours. 1 minute, 1 minute. Okay. 1 minute. I'm asking you for the fourth one. Very good, very good. No, darling, you're wrong. No.
Less than minus.
Yeah, so Tanya and Santosh have got it right. No problem. See here. What comes after less than? What comes out? See, whatever comes after less than and more than should be written first. So what comes after less than? The quotient of X by Y. The quotient of X by Y. How do you write this? X by Y. And that should be written first. Less than means minus. And 5. If I'm not clear, I can repeat it. Yes? No, see here. Keep this less than separately. There's 5 here. Less than means minus. And the quotient of x by y means x by y. Now, which one to write first? 5 or x by y? X by y. Whatever is after than, less than, more than. So that one should come first. Less than means minus and then 5. Oh, you're saying, should you put a bracket for this, right? You can put if you want. Yes. That's only one thing, no? One term, you don't have to put a bracket. When there's more, if it's a monomial, don't put a bracket. If it's a multinomial, you should put a bracket. For a single term, you don't have to put a bracket. If it's more than one term, then put a bracket. So for the next one, no, 1 second. Yeah, let me ask Satakshi because you both already answered. Yeah, Satakshi, try this. You said this earlier, right?
Yeah.
The quotient of x by y means what, Satakshi? What do you this? The quotient of x by y. That means x divided by y. Added 2 means plus. The product of x and y. X, y. Product of x and y means x into y, which is xy. If it's into, you don't have to put it. The product of x and y means x into, the product of x and y means x into y, xy. 1 second. Quotient of x by y meaning x by y. No, 1 minute. I have not given the answer for this. Now the quotient of x by y added to, this one is added to something. This one is added to something which is already there. This is added to something which is already there. So what is already there? The product of xy is already there. And you're adding this one to it. The order is important. Though addition is commutative, the order is important. Now, you don't think in your mind that this teacher is mad. She does not know the rule. I said x by y plus xy, and she's telling the opposite. Both are correct. Both are correct. By value, both are correct. Expression wise, they are not correct. Yeah, see, this one is added to something which is already there. Okay, now supposing listen to this, children. Sorry. Now, supposing you've got 35 on 40. Okay. 35 on 40. A test at school, you've got 35 on 40. Then you see that the totaling is incorrect. So you go to your teacher. Okay. And she said, okay, add 2. Add 2. Add 2 means will you do 2 plus 35 or 35 plus 2? Because 35 is already there. Will you do 2 plus 35? That's correct, 37. But what does it actually? You already have 35 on your paper. Plus 2, 37. It makes a difference, right? You will not write 2 plus 35. You will not say, I got 35 marks, but the totaling was incorrect. So the teacher then gave me 2 more marks. 2 more marks. So you will not say, now I got 2 plus 35. You will say, now I have 35 plus 2.
I got 2 marks.
And the teacher is given that. Yeah, exactly. 2 plus 35 means you got only 2 marks and the teacher has given you 35 more marks. So that's important. That's what it is. So 1 minute. So the quotient of x by y, this one is added to something. It's added to something which is already there. This one is added to that. All right. So added to, it's added to this. So what is this one? xy. What is added? This is added. Added to. So remember this. Added to means after the 2 there is something. That one you should write first. Then plus xy. Yeah. Am I clear, children? Yeah. Okay, Tani.
X plus 5 minus 7.
Yeah. 7 taken. 7 is taken away from whatever is from something. Something is already there. From that you're taking away 7. your mother says, take 7 sweets from the jar. Take 7 sweets from the jar. So in the jar, there are already some sweets. From that, you're taking 7. So supposing there are 40 sweets in the jar. Okay. So 40 minus 7. She says, take 7 from the jar. So how much is in the jar? 40. You're taking 7. So how much is remaining? 40 minus 7. 7 taken away from. What is after from? Sum of x and y. So x plus y minus 7. Should put this in a bracket. Why? Because it's more than one term. Whenever there is more than one term, you must enclose that in a bracket. So sum of x and y means x plus y. And this is 7. Taken away means minus. Everything we have decoded. 7 is 7. Taken away means minus. Sum of x and y means x plus y. Everything we have decoded. Now the thing is, which one to write first? 7 or x plus y. After from, what do you have? X plus y. Whenever you subtract, whatever comes after from should be written first. So x plus y first. Yeah. Now this is one thing. Sometimes you're given algebraic expressions and you have to, yeah, you must make the statement. You must construct the statement in English. Yeah. Yes, Satakshi first, and then we'll take turns one by one. Satakshi. Read the statement. 7 times a number x . 7 times a number. What do you mean by 7 times a number x? 7 times means into. Okay. 7 times meaning 7 into x. Okay. 1 minute. 7 times a number x is 7 into x. Okay. And what is y less than z? What is y less than z? How do you write y less than z? Okay. Y less than z is y minus z or z minus y? Y less than z. No, I'll tell you one thing. 1 minute, 1 minute. If you answer, see, I'm breaking down the statement into pieces. If you can answer the pieces, I can put everything together and tell you the expression which you can understand. You answer my question. What do you mean by 7 times a number x? Times meaning multiplication. 7x. Now, tell me this one for me. What is y less than z? Y? Don't read this number. Don't read this number. Don't read this. What is y less than z? Is it y minus z or z minus y? It's one of the two. Z minus y. Y less than z. So it is z minus y. Less than, more than, whatever comes after that, write that first. Y less than, whatever comes after this, more than, less than, write that one first. Whatever comes after that, than, write that first. So z minus y. Now, is means equal to. Is means equal to. So 7x is equal to z minus y is the equation. This one is an algebraic equation. This one is not an expression. This one, for this statement, the result for this statement is an algebraic equation, not an algebraic expression, because it's an equal to sign. And from where did we get the equal to sign? Is. Is means equal to. So see, you'll have to break down the statement into pieces. 7 times, don't read this simply. 7 times x. What is 7 times x? 7 into x, 7x. Is means equal to. Then what is this one? Y less than z. Y less than z. Y less than z.
Oh,
Whatever comes after less than. Okay, if you pronounce it as z, then it is z.
Oh, okay. Can you use other than?
Can you use other?
Z?
You can't change because it's given z here.
Oh, is that now? I'm thinking it's equal to.
Oh, this one, huh? Okay, okay. This one is z. Oh, that was not clear, is it? Oh, I'm so sorry. I'm so sorry. This one is z, children. This one is z. Yeah, what happens? That middle portion is not visible. It's so faint. The middle, the Z connecting thing, no, it's very faint. It's not visible. That's okay. Good, you asked me, Santosh. This one is Z. It's given there. I'm not saying it's Z. It's given there. Very good. I didn't understand at first when you asked me. Oh, so sorry, children. So sorry. It's yeah, very sorry. Yeah, this one is given.
Just let us start this equation equal to something as a number.
Equation is a number.
No, not in algebra. They will not use this equal to as number. If 6 is equal to 6 is unequal to like that.
Yeah, it can be. So again, coming back, 7 times x means 7x. Y less than, don't read certain words, you know, if you remove certain words, still you can get the meaning. Remove those words. See, 7 times, oh, number x, remove that number. 7 times x. It's the same. Removing that word number does not change the meaning, right? So all those extra words, you remove it. So I'm removing this 7 times x, 7x. Y less than, I'm removing this word number. So y less than z is z less. What is after less than? Z. Write that first. Less than means minus y. Is means equal to. That's all. 7x is equal to z minus y. That's only the equation. It's an algebraic. Sorry. Very good. That's an algebraic equation. Why? Because there's an equal to sign. It's an algebraic equation. Yes or no? Expression. Yeah, that is in an expression. Very good. So I'll tell you. A very good question, Tanya. No, 7x is equal to 1 minute. Z minus y. Okay. Now on this side, if supposing along with the z minus y is one thing. If along with that there was some plus 7 or something, then you should put a bracket. There's nobody else, right? There is nobody. Z minus y is one thing. If you put a bracket here, then that means there is somebody else along with it. That's why you're putting it in a bracket. There is nobody. Then no, you don't have to put a bracket.
Yeah. Oh, I get it.
See, you're saying, okay, you're right in asking Tanya. Your question is, no, you said if there is more than one term, you should put a bracket. Yes, I did say that. Okay, now if you say now z minus 1, there are 2 terms. So put a bracket. Why you're not putting a bracket? I'm saying if I put a bracket, there should be somebody else there. There is nobody. Then it's okay if you don't put a bracket also. Now, it's not wrong if you put a bracket, but it's okay. So it's better don't put. There's nobody there. So if it is 7x is equal to z minus y, and there is something like plus 5, separately plus 5, then you should put this in a bracket.
Oh, it should be done, but expression there should be a simple and then but then it's not simple and then how
It's not mandatory. Okay, anyways, there is 7 there. There is 7. 7 is the constant. X, Y, and Z are the variables. And the operations you have multiplication, you have subtraction. Everything is there. if it's an algebraic expression, even this one is an algebraic expression. It's not mandatory that there should be a constant. It's not mandatory that there should be one constant, there should be one variable, there should be one mathematical operation, any combination. If it's an algebraic expression, it will have all this. There'll be constant. See, like when you go to a zoo, you cannot say that there are no elephants in the zoo, so it's not a zoo. No elephants are there, so it's not a zoo. Or she says, I don't see any giraffe here, so it's not a zoo. No. If it's a zoo, it's a collection of animals. There can be a few to many animals. Still, it is a zoo, right? In the same way here, there can be one mathematical operation or more than one, or there may not be even one mathematical operation. There may be one constant, two constants, or no constants. There can be one variable, two variable, but there should be a variable. But you know what? When you come to higher classes, you will understand that even 7 is an algebraic expression because there is a constant there. 7 is an algebraic expression because there's a constant. X is an algebraic expression because there is a variable. So they can be one to many, anything, variable, constant, mathematical operations. But just writing a plus sign and saying that this is an algebraic expression is wrong. You cannot just put a plus sign and say it's a mathematical operation, so it's an algebraic expression. No. You can't just put a minus sign and say it's an algebraic expression. No. If I write the number 10, yeah, it is an algebraic expression. If I write 10, if I write only x, yeah, it is an algebraic expression. If I write x plus 10, yes, it is an algebraic expression. Yeah. Write the following in the exponential form. Again, there's a new term. Exponential form. Now, let me ask you a question first. What is 6 plus 6 plus 6 plus 6 50 times? 6 added to itself 50 times. What's the result? 6 into 50. Because repeated addition is multiplication. Because repeated addition is multiplication. Correct? Correct. So it is 50 into 6. 6 is added to itself 50 times. So 50 times 6 it is. It's 50 times 6. 50 times 6, which is 50 into 6. Agree, all of you? Now, like repeated addition is multiplication. Repeated multiplication is written in the exponential form. When do we have the necessity of using the exponential form? The question is, how do I know now I should use the exponential form? It'll either be given the question or you can figure it out yourself. How? If you see repeated multiplication, that is 5 multiplied with itself. Supposing you had this one. What I asked you is 6 added to itself 50 times. And this is nothing but 50 times 6. 50 times 6, which is 50 into 6. But if you had 6 into 6 into 6 into 6 50 times, this is repeated multiplication. A repeated multiplication is written in the exponential form. Now, in the exponential form, you have 2 characters. One is called the base, the other is called the power. Okay, one is called the base, the other is called the power. Okay, now the base is 6. Whatever is repeating, that becomes the base. And the number of times it is repeating becomes the power. 60 raised to the power, 6 raised to the power 50. 6 raised to the power 50. So 6 into 6 into 6 into 6. Repeated multiplication is written in the exponential form. Repeated addition is multiplication. 6 added to itself 50 times is 50 times 6, which is 50 into 6. But 6 into 6 into 6 into 6, 6 multiplied with itself 50 times is written in the exponential form. So you have to write two things, base and power. What is the base? What is repeating? 6. That becomes the base. How many times? 50 times. That becomes the power. The number of times it is multiplied becomes the power. So 6 raised to the, how do you read this? 6 raised to the power, raised to the power 15. 6 to the power 50. 6 power 50. Fifty is multiplied with itself 50 times. 50 to the power 6. 1 second, wait. No. Anything. No. It's not like that. It's not that the smaller number becomes the base and the greater number becomes the power. No. The power is always the number of times. 50 times, 100 times, that becomes the power. And what is multiplied 50 times? 6 is multiplied with itself 50 times. That 6 becomes the base. Sorry? What's the answer you're asking?
She's telling them it's wrong because this answer is wrong because the multiplication is common.
No. What? Okay, multiplication is commutative. Yes, so here it matters. If you write 60 to the, these are not the same. 50 to the power 6 and 6 raised to the power 50, they're not the same.
They're different.
They are different. Okay, let me give you an example for them. Let us understand what is. See, if you write 3 square, okay, and 2, okay, see, exchanging. Base is 3, power is 2. Base is 2, power is 3. Okay, now what is 3 squared? 3 into 3, 9. What is 2 cubed? 2 into 2 into 2, 8. They're not the same. She's telling, her question is, nice question. Her question is, if you exchange the base and the power, is it the same? Because her question is 4 into 5 is the same as 5 into 4. And you're saying repeated multiplication is exponential form. So her question is, then is 5 to the power 50 to the power 6 and 6 to the power 50 the same? Is her question. Are they the same as her question? 50 to the power 6 and 6 to the power 15, they're not the same. You can take an example for that. So simple, very simple example.
I did the exact same thing. Exact same.
Okay, one second. So if it is 4 to the power 2 and 2 to the power 4, what is 4 to the power 2? 4 into 4, 16. In this case, it. Yeah. So see here, in this case, it is the same. I'm giving an example where it's the same. 2 to the power 4. What is 2 to the power 4? 2 to the 4, 4 is 8, 8 is 16. What is 4 to the power 2? That's also 16. So now with this example, you cannot conclude that, okay, every time it's the same. No. Take this 5 squared. What is 5 squared? 5 into 5, 25. What is 2 to the power 5? 2 into 2 into 2 into 2 into 2. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. 16 into 2, 32.
Okay, now again. Yeah.
Quiet. No, quiet. Listen here. Okay, see the power The power. No, I think you must sit behind because since you're sitting in the front, you know, any action you do disturbs the others also. The power says, look at the board, children. The power says how many times the base has to be multiplied with itself. The power says, excuse me, the power says how many times the base has to be multiplied with itself. That's the rule. Now, if we say 2 to the power 7, what is the power? 7. The power says how many times? 7 times. The power is 7 times. 7 times what? Multiply 2 with itself 7 times. Multiply the base with itself 7 times. The power always says the number of times. The power always says the number of times. 7 times. 7 times what? Multiply 2 with itself 7 times. So it is 2 into 2 into 2, 3 times, 4, 5, 6, and 7. All right. Now what is 2 into 2? 4. What is 4 into 2? 8. 8 into 2? 16. 16 into 2? 32. 32 into 2? 64. 64 into 2? 128. 128 is the answer. 2 to the power 7 is not 14. Not 2 sevens are 14. 2 raised to the power 7 is not 2 sevens are 14. 2 raised to the power 7 is 7 times. 2 has to be multiplied with itself 7 times. Okay. Now tell me what is. Express this. Yeah.
So A.
Excuse me. See the question. 4 to the power. How many times? How many times, Satakshi? From where do you get the number of times? From the power. So how many times? 5 times. What should be written 5 times? 4 should be written 5 times. 4 should be multiplied with itself 5 times. So what should I write? How many times? What is this one? What is this one? How many times? How many times? 4 times. What should be written 4 times? 5 should be written. 5 should be written 4 times. And what's the connecting sign?
Multiplication.
So 4 is 4 times. 1, 2, 3, 4 times. That's all. 4 will not come here. 4 times. What should come 4 times? 5. The base should come. What is 3 to the power 6? How many times? 6 times. What should be written 6 times? What should be written 6 times? 1, 2, 3, 4, 5, 6 times. Yeah. Whenever you see an expression in the exponential form, it is multiplication only. No. If it is repeated addition, it is multiplication. If it is repeated multiplication, exponential form. Okay, one more thing. Now, Satakshi, tell me what is Satakshi. Not the answer. Yeah, yourself. No. 2? No. Is it repeated addition or multiplication? So repeated addition is what? Why are you saying power then? What's the answer? It is 6 times 2, right? 6 times 2. What is 6 times 2? 6 into 2. 12. Answer is so. So 2 is added to itself. Quite. 2 is added to itself 6 times. So 6 times 2. 6 into 2. Now what is this? Two is multiplied with itself 6 times. Not 2 powered by 6. 2 raised to the power 6. 2 raised to the power 6. 2 power 6. So this is repeated multiplication to be written in the exponential form. So how many times? 6 times. That 6 will be the power. And what's the base? 2 will be the base. All right. All right, children. So that's it for today's session. Thank you so much. Good night. I need to share some more instructions. Please